Okay, we've discussed the classic Young double slit experiment with light. The next stage is just a variation on this, but we slightly changed the slits that we're shining the light through. So if I draw a very magnified version of the kind of double slit that we tend to use for the Young's experiment, then what a diffraction grating is just a regular pattern, not just of two slits, but of lots of them. Okay, so something like this. I'm drawing it badly because they would be very precisely drawn or scored. Okay, a whole load of them, a whole continuous spectrum of them. Okay, and typically the comparison I'm showing here, maybe even an exaggerated form is present. The length of these, I guess, is the same. So this is the slide we put in front of the laser for the double slit experiment, and this is a diffraction grating we can put in front of a laser. The difference are we've got lots of slits instead of two, and typically these slits are much closer together, and probably narrower than these two. Okay. And when you shine your laser light through these at a screen, well, we remember that. I'm sort of drawing this fairly schematically, but imagine shining the light through these and looking at the screen over there. What we noticed about this, I'll change colour, is that we had a fringe and then a gap and then a fringe, then a gap and then a fringe and then a gap. But the fringes were about the same width as each other. Okay, they weren't totally crisp at the edges, and we got a kind of high and low pattern, something like that. Now, the difference we notice on the screen when we go from maybe that to that and keep other things in the experiment the same is that instead of having these kind of blurry fringes, we have single, very intense points. There's just a spot in the middle, just like a single laser beam. And then really quite some distance away, there's another bright spot here and another bright spot here. But whereas if we just magnified the central three fringes there, we might see them almost blurring into each other. Okay. Here there are very separate spots, and the spots are very bright, they're very clear and sharply divided. And we can explain why that happens, why we get that difference. The principle is exactly the same as with two slits, but with a diffraction grating, well, the first difference, that the separation is much wider, is a consequence of the lines being closer together. We had this formula lambda equals AX over D, okay? Well, lambda's fixed. What I've effectively done is made the separation of the slits here go from A to some much smaller values, so A has got much smaller. D has stayed the same, lambda stayed the same, so X, the separation of the fringes, has got to get much bigger. So it's not surprising they're further apart, but we'll explain the other things in the next video. And we'll also derive a formula that's more suitable than this one. This formula, if you watch the derivation of it, we did actually have to use an approximation that depended on the separations of the slits and of the fringes being very small compared with the distance from the laser to the screen. Now, in diffraction gratings, there's a much wider separation here, and that approximation is less good. So there's another formula that we can derive for use with diffraction gratings, and that will be in one of the later videos as well.